Welcome to this video. So in this video I'm going to discuss question number 10, 11 and 12 of KCET 2019 chemistry, right? So the question number 10 is R and S form benzyl benzoate. It forms what? R and S forms benzyl benzoate when treated with each other, right? Hence P is, right? So they have given P when it is treated with hydrogen palladium in presence of barium sulfate, right? Poisoning they have made, we will get Q. The same Q treated with concentrated NaOH and dilute HCl will get product R and S, right? So this is product R and S, right? So but the problem is R and S, when they are treated each other, if they are heated each other, it forms what? Benzyl benzoate. Benzyl benzoate, right? And we have to tell what is P. Hence P is they asked what is P, right? So one of the easiest question it is, but see, a little basic you should know. So see, R and S when they are heated we will get benzyl benzoate, because when they are treated we will get benzyl benzoate. They have told what is the structure of benzyl benzoate. Benzyl means what? Benzene ring is there, to that CH2 group is there, right? That is benzyl. Benzoate, 8 means what? Ester is what? O CO, again benzene ring, right? So this is nothing but the benzyl. See, this is benzyl and this is benzoate. This is what? Benzoate. So this is the structure of benzyl benzoate, right? So this product we have to get, right? So this is, we will get this one when we treat R and S. So what might be R and S? See, if I break this bond, which bond? CH2O bond. We can't break the CH2O bond, sorry. If I can break this bond, see, always we know that C double bond O and O bond will be weaker. So this bond can be broken. If I break this bond, what I'll get? I'll get this thing. One is benzyl alcohol, CH2OH, benzyl alcohol. Along with that, I'll get what? Benzoic acid. Along with that, I'll get what? COOH, right? Just if I do hydrolysis, H will add here, OH will add here, right? Hydrolysis. OH will add to this carbon, H will add to this oxygen. So I'll get benzyl alcohol and benzoic acid. So this product I will get, right? So R and S treated, I will get benzyl benzoate. What is R? R is benzyl alcohol. What is S? Benzoic acid, right? So when we will get this product, see, Q, can we guess? Yes, easily we can guess Q, because Q should be what I have added, concentrated NaOH followed by first step concentrated NaOH, second step dilute HCl I will add. To this Q, if I add concentrated NaOH, dilute HCl, I will get this benzyl alcohol and benzoic acid. So here I will get reduced product and I will get oxidized product. Then it should be Kenny-Zaro reaction. What it should be? It should be Kenny-Zaro's reaction. Kenny-Zaro's reaction, right? Kenny-Zaro's reaction means reagent, can we guess? So in Kenny-Zaro's reaction, the reagent Q might be this thing only. In Kenny-Zaro's reaction, there should not be any alpha hydrogen and it should be only aldehyde. So this is aldehyde, no doubt, and it doesn't have any alpha hydrogen, no alpha H. And we are adding concentrated NaOH and dilute HCl in second step. So we will get one benzoic acid and what? Benzyl alcohol, right? So Q might be this aldehyde, benzaldehyde, right? So we know Q. Then what must be the P? So P should be what to get Q? Here reagent is hydrogen palladium in presence of poisoning. We are doing BaSO4. This reaction you have studied in aldehydes ketone chapter, in which P must be this one, benzene ring, to that COCl is there, then benzoyl chloride we call it as. This is what? Benzoyl chloride. If benzoyl chloride is there, if I add hydrogen palladium in presence of barium sulfate, I'll get what? Benzaldehyde. Benzaldehyde treated with concentrated NaOH dilute HCl, I'll get what? These two products. One is benzyl alcohol, other one is benzoic acid. This is simple Kenny-Zaro's reaction. This is also a named reaction, hydrogen palladium in presence of barium sulfate. Can you tell what is that named reaction? Just you go through the NCERT, you will get to know, right? So answer for the given question is D. C6H5COCl. Benzyl chloride is the P. What? Hence P is, they have asked P. The P is C6H5COCl, right? So benzyl chloride C6H5COCl we will write. This is C6H5 benzene ring COCl. So this is benzyl chloride, right? So coming to the question number 11. So question number 11 is, among the following the main reactions occurring in the blast furnace, right? The blast furnace during the extraction of iron, they have asked from hematite ore. From hematite ore, right? Blast furnace, you know, this is from the chapter general principles and processes of isolation of elements, right? So this is blast furnace. Here heating will be there, right? And there will be reactions here with the different temperature, and we add these charge here, right? Ore and reducing agent coke and the limestone CaCO3, right? Ore will be hematite ore Fe2O3. Reducing agent is coke COK, carbon, and this one is slag, which forms slag, right? We know that on heating it gives calcium oxide. Calcium oxide react with silicate SiO2, it forms CaSiO3, right? So this is the one reaction in which there will be formation of slag, and that will be reduced in this blast furnace, right? So one reaction is this reaction. See here they have given option A 1 2 3 4, right? Everywhere it is arrow here, just you have to write it. So this is the reaction which happens in blast furnace, right? And this FeO will be there, right? This coke is not a reducing agent. It is reducing agent, no doubt, but around at temperature 1000 Kelvin or 1000 degrees Celsius, this is not a reducing agent. The good reducing agent will be carbon monoxide, that you can see from Ellingham diagram. Ellingham diagram. If you have Ellingham diagram, then you can tell that at this temperature, which is good reducing agent, carbon monoxide will be good reducing agent compared to carbon. So this Fe2O3 hematite ore, when treated with carbon monoxide, this will reduce this Fe2O3 into Fe, and this carbon monoxide oxidizes to carbon dioxide. So it is good reducing agent here. It is good reducing agent, right? So this is the reaction happens in blast furnace. What reactions? One is formation of CaSiO3, other one is Fe2O3 will be reduced by carbon monoxide to form Fe and carbon dioxide. So these two reactions will happen in blast furnace. This FeO plus SiO2 FeSiO3, this reaction doesn't takes place here. Carbon can't act as reducing agent at given temperature in blast furnace, so this reaction also doesn't happen. So 1 and 4 are the correct option. 1 and 4 means that is option number 3, or the option number C is the correct answer for the given question 11. Now talking about question number 12. Which of the following pair contains two lone pairs of electrons on the central atom, right? So they have given options A, B, C, D. We have to tell in central atom, not metal atom, central atom, which one is having lone pairs, right? Let us solve one by one. Option A, they have given H2O and NF3. You should know the structure. If you are thorough with chemical bonding, you can easily draw the structure, right? There is trick. If you want, you have to comment it so that I will explain it. So water structure will be like this, which will be having two lone pairs. So this is central atom, which is having two lone pairs. But here NF3, we know that it has got only one lone pair. So this is not the answer. A is not the answer, because they asked two lone pair on central atom, right? Two lone pair should be there, but here it has two, here it is having only one. So this is not the answer. Talking about B, I3 plus and H2O. In JE, several times they have asked the structure of I3 plus or the hybridization of iodine in I3 plus, right? So the structure of I3 plus is like this. This is I3 plus, right? Right. So this is a central atom. So this is the formula of I3 plus, in which this central atom iodine has two lone pairs. And what is water? Yes, it also has two lone pairs. So the answer will be B. But let us solve C and D also, so that you will get to know the structures of all. So talking about C, that is SO42 minus, and it is H2S. So the structure is simple. SO42 minus is tetrahedral structure. You can draw S double bond O, O minus and O minus. So this is tetrahedral structure. This sulfur doesn't have any lone pairs, zero lone pair. Whereas H2S, it is same as H2O structure. Instead of O, it will be having central atom S. So hydrogen will be there, two lone pairs here, two lone pairs. It has got two lone pairs, it doesn't have any lone pair. So C is not the answer. Talking about D, XCF4 is there, XCF4 and NH3 ammonia. XCF4 structure in P block elements, you have studied that 4 fluorine will be in one plane like this. All these xenon and 4 fluorine will be one plane. One lone pair will be above the plane, other lone pair will be below the plane, right? So it has got two lone pairs, no doubt. But ammonia, it has got only one lone pair. See, NH3, only one lone pair is there. So one lone pair, but it both are not having two lone pairs. So this is also not the answer. The correct answer, the pair which contains both two lone pairs are I3 plus contains two lone pairs and H2O contains two lone pairs. So answer B is the correct answer for the given question 12.